Okay, now we will be having an electric potential problem solving. So sample problem number 1. Two charges, charge 1 is equal to positive 5 nanocoulomb and charge 2 is equal to negative 7 nanocoulomb are separated by 8 centimeters. We need to calculate the electric potential at point A on the figure shown. So this is our figure. Then this would be the point A that we need to calculate the electric potential. So this is our source charge number 1 and this is our source charge number 2 with their specific value of their charges. So first, in solving a problem, we need to write all the given values that we have on our problem. So we have charge 1, which is equal to positive nanocoulomb, and we need to convert this to our SI unit, which is in coulomb. So whatever the value of your nanocoulomb, we need to multiply 10 raised to negative 9 to make it in coulomb. So charge 2 is negative 7 nanocoulomb. The value in coulomb would be times negative 7 times 10 raised to negative 9 coulomb. Next is the R sub 1, which is the distance from point A to source charge number 1, which is 6 centimeters, and we need also again to convert it to SI unit, which is in meters. So 6 centimeters is equal to 0.06 meters. In R2, that is the distance from point A to source charge number 2, and that is equal to 2 centimeters. And 2 centimeters is the value in meters would be equal to 0.02 meters. So these are all the given values that we needed for us to solve the electric potential in point A. So next is we need to write what is asked in the problem. So the electric potential at point A is what is asked in the problem. So that would be the quantity that we need to find out. So V, or the electric potential, is equal to electric potential sub 1 minus electric potential sub 2. Electric potential sub 1 minus electric potential sub 2 is also equal to the electric potential is equal to the coulomb's constant times charge 1 over the distance between the point and the source charge. So that would be R1 minus K, coulomb's constant, times source charge number 2 over the distance between point A to source charge number 2. By substitution, we have here electric potential is equal to the source coulomb's constant, which is 9 times 10 raised to 9 Newton meter squared over coulomb squared. Quantity, we need to multiply this to the source charge number 1, which is 5 times 10 raised to negative 9 coulomb, all over the distance of point A to source charge number 1, that is 6 centimeters, and that is equivalent to 0.06 meters. So minus, substitute again, coulomb's constant, 9 times 10 raised to 9 Newton meter second over coulomb squared. Substitute Q2, or the source charge 2, which is equal to 7 times 10 raised to negative 9 coulomb. Why did I write only 7, not negative 7? Because this would be an absolute value. So the sign of, or the charge of our source charge will not matter if it's positive or negative, because that would be inside our absolute value. It would be 7 times 10 raised to negative 9 coulomb, all over the distance between the two. We have 0.02 meters. So by solving, it will give us the answer. But before that, there would be unit that needs to be cancelled out in our equation. That would be coulomb, and one coulomb here, because this is C squared, there is only one coulomb here, so sara lang ang cancel. Next we have meter. So sara lang sa dalom, darwa sa babaw, so sara lang makancel, mabilin si meter. Same with the other equation, si coulomb nga sara kay si meter nga sara. Then by that, we will be having the answer, negative 2,400. What would be our unit? So nabilin sa babaw is Newton meter. So that would be our unit over coulomb. So makita natin kung anong mabilin nga unit by having a cancellation process in our units. And Newton meter over coulomb, that is Newton meter is equal to joules, and coulomb is equal to, of course, coulomb. So sorry, naganakan nga animation. So, joules over coulomb here is equal to volts. So, 1 volt is equal to 1 joule over 1 coulomb. Therefore, our electric potential at point A is equal to negative 2,400 volts. The negative here indicates that point A is on the electric field of negative charge Q2. So, dyan ta nasa silid kang electric field kang source charge 2. That's why it is negative. Okay, that would be the sample problem of the electric potential. Electric potential difference problem solving. Sample problem number 1. Charges in point A is equal to positive 5 nanocoulomb and point B is equal to negative 2 nanocoulomb are separated by 80 centimeters. Calculate the electric potential difference of 2-point charges as shown on the figure. So this is our figure. Wait, I'll be getting my laser pointer. Our figure, we have here point A and point B. We need to calculate the electric potential difference between these 2-point charges. Okay. So first is, we need to write all the given values that we have in our problem. So we have a charge at point A is equal to positive 5 nanocoulomb. Again, we need to convert it to coulomb first by multiplying 10 raised to negative 9. That will make it in coulomb. Now, we have a charge in point B that is equal to negative 2 nanocoulomb. That is also equivalent to negative 2 times 10 raised to negative 9 coulomb. What else? We have a distance from point A to point B which is equal to 20 centimeters plus 60 centimeters. That will give us 80 centimeters and that is equivalent to 0.8 meters. Now, we have all the given values. Next is we need to find out what is being asked from the problem. So what is being asked is the electric potential difference. So that is denoted by a small triangle and electric potential symbol. So electric potential difference is equal to point B electric potential minus point A electric potential. Now, substituting, we have here the electric potential equation is coulomb's constant times the charge in point A over the distance between point A and point B minus the coulomb's constant and the charge in point B over the distance between the 2 points. So by substitution, we have here the coulomb constant which is equal to 9 times 10 raised to 9 Newton meter squared over coulomb squared times the value of our source charge point A, that is 5 times 10 raised to negative 9 coulomb over 0.80 meters minus the coulomb's constant here, that is 9 times 10 raised to 9 Newton meter squared over coulomb squared multiplied by the charge. Again, we do not have negative 2 here as the charge of charge B because of the absolute value. It does not matter the sign of our charges. So that would be 2 times 10 raised to negative 9 coulomb all over 0.8 meters. So by solving, we need to cancel out the like terms. So we have 1 column here on the above the fraction bar, then we have 2 columns below the fraction bar. So sara lang ka column ang makancel, same with meters. So sara makancel man. Okay, ang mabilin is we have answer as 33.75. You could press your scientific calculator there for you to be able to practice plotting the equation to your cycle. Okay, so practice yung gid hasta mabuol nyo sakto. So make use of grouping, so make use of parentheses, pero dapat kabilog ng parentheses ang gamitin ninyo for you to be able to have or to arrive to the correct answer. That would be 33.75. So the unit would be, ang nabilin is Newton meter over coulomb. So Newton meter is also equal to joules, and coulomb is of course equal to coulomb. So 1 joule over 1 coulomb, that is equal to 1 volt. Therefore, the electric potential difference of 2-point charges is equal to 33.75 volts. Now, we will be having the electric potential energy problem solving. electric potential is different from electric potential energy. So an electron accelerated from rest through a potential difference of 15 volts. What is the change in electric potential energy of an electron? So solution, we have given the change in, or the potential difference, which is equal to 15 volts, or equivalent to 15 joules per coulomb. Okay, the charge of the electron is equal to negative 1.6 times 10 raised to negative 19 coulomb. Din ko siya ginbuol. Recall that the charge of electron in previous discussion is equal to positive or negative 1.60 times 10 raised to negative 19 coulomb. So it's either the electron or proton. So we are talking about here electron. Of course, the sign would be negative. But if I talk about proton, that would be positive 1.60 times 10 raised to negative 19 coulomb. Now, we need to find the change in electric potential energy. So electric potential energy is denoted by big letter U. So why did I put triangle here beside the big letter big letter U? Because we are looking for the change. So basta may change kita, meaning from final ginmaynusan natin kang initial. That's why this triangle denotes that there is a change in a certain quantity, and we are talking about here the electric potential energy. So change in electric potential energy is equal to charge times change in potential difference. So by substitution, we have here change in electric potential energy is equal to negative 1.6. This is the Q, or the charge, times 10 raised to negative 9 coulomb, multiplied by the change in potential difference. So that is already given from the problem. That would be 15 joules per coulomb. Now we need to cancel out like terms. So C sa babaw, C dyan sa dalang makancel. Ang mabilin is joules. So negative 1.6 times 10 raised to 9 times 15. That would give us negative 2.4 times 10 raised to negative 18. And the unit would be joules. So therefore, change in electric potential energy of an electron is equal to negative 2.4 times 10 raised to negative 18 joules.